AI token prices just dropped 90%. Your total bill just tripled. You're paying more for cheaper AI. This is the AI inference paradox. Cheaper models trigger usage explosions that crash into hardware bottlenecks, revealing how to fix the bill. We'll cover the adoption J-curve, the memory bandwidth trap, the sequential decoding bottleneck, and 3 engineering fixes. Ignoring this will bleed your budget. Think of your GPU as a Ferrari engine stuck in gridlock traffic. The engine can go 200 miles per hour, but it's waiting for the road to clear. You have massive compute power, but it sits idle waiting for data to arrive from memory. First, the adoption J-curve. Inference is the recurring bill. It now eats 60 to 80% of your compute spend. Cheaper tokens don't just save money, they unlock usage. Coding assistants run more. Agents handle complex workflows. Usage scales faster than the price drop. You save 90% on the unit cost. But if usage triples, your total bill still rises. Lower barriers trigger exponential demand. The crisis isn't that AI is too expensive, it's that pricing models haven't caught up to hyperscaling. But volume isn't the only problem. The hardware itself is fighting you. In a second, I'll show you the hidden tax that makes your GPU sit idle even when it's working hard. Second, the memory bandwidth bottleneck. GPUs are marvels of parallel processing, but inference is memory bound. The bottleneck is bandwidth, not compute. You have massive power, but it sits idle waiting for data. This creates a token tax. You're paying for hardware that's underutilized. The data pipeline can't feed the cores. In inference, model weights load for every request. The KV cache stores every token state. Imagine the KV cache as a notepad for the conversation. Every word you write fills a line. If the notepad fills up, you have to stop writing to get a new pad, or rewrite the page. That takes time. That's the memory tax. Memory fills up. The system throttles requests. Throughput drops. The effective cost per token spikes. You're paying for the compute and the memory overhead that slows it down. And the hellish, twary, and that memory tax leads to a weird timing problem that kills throughput. Stick around, because the solution isn't just buying more GPUs. It's a specific decoding trick that changes everything. Third, the sequential decoding trap. Training parallelizes thousands of tokens. Inference is sequential. You cannot generate the end before the beginning. Each token depends on the last, a chain you must execute step by step. This creates a latency trap. The prefill phase processes the prompt fast. The decode phase cannot. You generate one token, feed it back, generate the next. This loop caps throughput. You can't batch requests efficiently. The hardware manages many active conversations, each waiting for its turn. This serialization forces you to buy more GPUs to handle the load. Latency kills efficiency. If your GPUs wait for sequential outputs, you're burning money without producing value. So how do you engineer around these bottlenecks? First, context management. The KV cache grows with context length. Every extra token eats memory. Truncate irrelevant info. Summarize long documents. Reduce the memory footprint. Second, check your decoding engine. High latency means you're stuck in the sequential trap. Look for speculative decoding. Imagine speculative decoding as a speed reader. Instead of reading every word one by one, you skim a paragraph. You guess the words. Then you verify them. If you're right, you zoom past. If you're wrong, you backtrack a bit. But you still move faster than reading every word slowly. This breaks the sequential penalty, improves throughput, lowers costs. Third, adopt a model hierarchy. Not every task needs the biggest model. Use distilled models for simple queries. Save the heavy hitters for complex reasoning, balance cost and performance. To recap, the adoption J-curve proves volume growth outpaces price drops. The memory bandwidth bottleneck shows GPUs sit idle waiting for data. The sequential decoding trap forces GPUs to generate tokens one by one. The 3 engineering fixes are context management, speculative decoding, and model hierarchies. The inference paradox resolves when you see the bill as a function of volume, memory efficiency, and latency. Cheaper AI doesn't save money. It rewards efficiency. The organizations controlling costs are the ones optimizing token flow and batching, not just chasing lower unit prices. As prices normalize, token optimization is no longer optional. It's essential for every budget. Inference cost isn't just price per token, it's volume, memory efficiency, and latency. If you want AI explained without the hype, subscribe. That's what we do here, daily. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.